here's what I'm going to melt your brain. Okay. We have these conversations. I have these conversations at least once a week with people, and it has to do with fiber polarity. What's the right way to do stuff? What's the easiest way to do stuff? There's 3 schemes that were available to you to approach polarity that were recognized by the standards when we were talking about duplex fiber. In other words, one transmit, one receive fiber. There's type A, where everything in the permanent portion of the infrastructure was straight through pin to pin, 1 to 1, 2 to 2, 3 to 3. No surprises. You knew exactly what it looked like. Your job was to decide where in that circuit you're going to add a patch cord that makes the flip. Puts you in the driver's seat. Okay. People will argue, oh, I don't want to have to stock 2 different types of patch cords. Oh, I don't want my technicians having to think about that. Right? To me, this makes the most sense. Right? No surprises in the fixed infrastructure. Okay. For duplex fiber, that's not a big deal, right? For duplex fiber, if my guy got out there and he didn't have the right cord, he'd just say, oh, okay, I'm just going to flip the polarity and plug it in. Hey, it works, right? Think about parallel optics. Can I do that now? I got 4 transmit and 4 receive fibers on an MPO connector. I can't move them. Can I switch that polarity? No. No. So what you do now in terms of how you plan for polarity has a big impact if you're planning on using 40 and 100 gig or whatever comes after that because of the parallel optics. Okay? My belief, our corporate belief, is that this makes the most sense because there's no surprises in the infrastructure. You know what you need to do, and you do it where you want it. Okay? Everything is straight through except for the patch cable that you apply somewhere that makes the flip.
And I'm sorry, why would I use a flip?
Well, because so in optical fiber, right, I've got a transmitter and a transmitter and a receiver, and they can't, transmitters can't talk to transmitters.
Oh, okay. As a physical make of the units.
Right.
So they have to be.
Transmit has to talk
to receive,
which means that at some point you've got to do that. Right. Okay. Method B was also one that was acknowledged by the standards, and in this one, the patch cords at both ends were the same. Hey, I could stock one type of patch cord and be done with it, right? But here you've got a cassette that is straight through, you've got a trunk cable that rolls it, and then you've got an inverted cassette at the opposite end that rolls it back to basically get you to the point where transmit is to receive within the fixed infrastructure. For duplex fiber signaling, 2 strands, worked okay, no problem. But think about that when you start to think about 40 gig, 100 gig, where you've got multiple parallel optics. It gets very, very confusing. Okay, where are the 4 transmit and receive fibers? Well, they're at 1 and 12 on the MPO trunk. How do they end up on the other side? It's goofy. And the other problem with this one is that if you're using angle polished connectors, it doesn't support it. You know why? Because the matings are all key up to key up. You can't do key up to key down. Okay, the last method that was acknowledged for duplex fiber signaling was what was called pair flipped. Okay, where somewhere in the circuit, an odd number of components, whether it was one cassette, a cassette, a trunk and a cassette, whatever, had the pairs flipped. Okay. So as long as it was an odd number, you knew that you were going to go end to end and they were going to be rolled, just that single pair.
So what's your term for cassette exactly?
So this would be a cassette. So if I'm talking about like a pre-terminated solution where I've got the LC connectors on the front and the MPO trunks on the back.
That's considered a cassette.
Right.
And he mentioned angle polish. When you go single mode and a cassette, almost always the interconnect is going to be angle polish to reduce reflectance.
In a lot of cases, yeah. In a lot of cases. So this was another method. But now if you think about this one, okay, now I'm taking individual pairs and flipping them somewhere in that infrastructure. How's that going to work for parallel optics? Not well at all. So as a result of that, the standards for parallel optics don't recognize this one anymore. Doesn't mean you can't use it if you have it, but you got to go through a big dance with patch cords to get it the right way to support it. Okay. Point of that argument is that you got to think it through. Plan it. So pick what's right for you, stick with it. If you've got existing plant that is one particular type of polarity, you might want to stay with it. Because if you start mixing it, that's where it gets really ugly. Really, you're nodding your head back there, right? If you've lived it, you know. Okay, termination methods. So I have fiber, how do I terminate it? Well, there's a couple different ways that are very common. I can buy factory connectorized pigtails. So I've got a bulkhead adapter that has connectors that already have pigtails on them. And what I do is I fusion splice them to the bulk fiber. This is the lowest loss method of doing it because a fusion splice is typically very low in loss in comparison to a connector mating or field connector. Takes a bit of skill because you got to know how to cleave the fiber and operate the splicer. Most splicers today make it pretty easy. Okay? The end face quality is always consistent because they're factory polished end faces. So it's pretty quick to do. Contractors will generally charge a fair amount of money for splicing because they got to pay for the splicer. But in my opinion, it's one of the best ways to do it if you want low loss and consistent end face quality. This one is becoming very, very popular. This is the fully factory pre-terminated plug-and-play solution where the technicians don't have to terminate anything. All they have to do is make sure they have clean and examined end faces and plug stuff together. Right? We showed before those trunk cables, right? If I just take one of those, it would be as simple as, okay, I'm not terminating a thing. I'm going to clean that end face. I'm going to inspect it, make sure it's clean, and boom, it's terminated. Done. The other thing about this is that it's reusable. Okay, I can unplug this stuff and plug it. You know, as long as the lengths are right on it, and it's the right polarity and whatnot, I can use that stuff anywhere I want.
How many times?
Scores of times.
But standard.
Scores of times.
Scores.
Yes.
Scores of standards.